Hey everyone, welcome to another deep dive with us. This time, we're taking a look at Week 1 Applied Statistics.
Yes, looks like you've already got a great start on this stuff, which is awesome. Statistics can feel a bit like, yeah,
Like learning a whole new language?
totally, but like once you kind of start to get it, it's really something.
Oh, absolutely. It's incredibly empowering to be able to
Yeah.
look at data and make sense of it. And that's what we're here for, to make sure that that power feels less like, rocket science and more like a tool you can actually use in your everyday life.
I love that. That's a perfect way to put it.
So whether you're, analyzing research for a paper or just trying to understand like the graphs they put up on the news.
Totally, it's everywhere.
Yeah,
Right.
I like
So
that.
much information we see is based on statistics. So like
Wow.
having a good understanding of it, that's really valuable.
Absolutely. So let's dive right in. Week 1 here starts off with visualizing data,
Yeah.
which makes a lot of sense. Before you can even think about, crunching numbers, you have to be able to actually see what the data looks like.
It's like, think about being a detective at a crime scene. You wouldn't just start, interrogating suspects randomly, would you?
Hopefully not.
You got to kind of survey the scene first, get the lay of the land. That's what graphs are like. You get that initial lay of the land of your data.
Oh, I like that a lot.
Yeah.
So instead of yellow tape and footprints, we've got things like histograms, box plots, and density curves. Can you break those down for us a little bit?
Yeah, definitely. So let's start with histograms. So imagine you're looking at the heights of everyone in your class.
Okay.
A histogram would use bars to show how many people fall into different height ranges. And then the shape of those bars, whether it's, symmetrical or if it's leaning to one side, that tells you a lot about how the heights in the classroom are distributed.
Okay. So if most of the people in the class are kind of clustered around the same height, the histogram would look pretty symmetrical, like that bill curve, right?
Exactly. And then,
Okay.
if you had, a couple of basketball players in your class that were super, super tall,
Right.
the histogram might be kind of skewed to the right, meaning like there's this tail of taller people extending out from the majority.
That makes sense. So histograms are great for giving us that overall picture, but what about box plots? Those seem a bit more simplified.
Yeah, they are. So think of a box plot as a kind of like a 5-number summary visualized. So you have a box that represents the middle 50% of your data,
Okay.
and then you have these whiskers that kind of extend out to the minimum and maximum values.
Got it.
And the median, which is that middle value, when the data is sorted, that's a line that goes right through the middle of that box.
Okay, so the box shows us where the majority of the data is, and the whiskers kind of show us that range, from the shortest person to the tallest person.
Yes, exactly. And here's the cool part. Box plots can help us spot outliers. Those data points that are just way off from everything else.
Oh, right.
So if we stick with the height example, if you had someone in your class who is exceptionally tall, their height would show up as like a little dot beyond the whisker, indicating that they're an outlier.
So outliers are like those plot twists in a good book.
Yes.
You kind of have to stop and say, wait, what's happening here?
Precisely. And it's super important to identify them because they can really skew our analysis if we're not careful.
Right. We don't want that one really tall person throwing off our understanding of the average height.
Exactly.
Okay, and then last but not least, density curves.
Right. So these are a bit more abstract. They're kind of like smoothed, idealized versions of histograms,
Okay.
and they represent probability distributions for continuous variables. So things like height, weight, time, things that can take on any value within a certain range.
Okay. So while a histogram uses those separate bars, a density curve is more like a smooth line.
Exactly. And the key with density curves is that the area underneath that curve, that equals 1, which represents the entire probability.
Got it.
And then the mean, or the average, is like the balance point of that curve. And the median that divides the area under the curve in half.
Okay. So we've covered our visual tools now. Histograms for the big picture, box plots for that quick summary, and then density curves for those probabilities. But how do we start to summarize the data with actual numbers?
That's where we bring in measures of central tendency and spread. Those give us numerical snapshots of what's happening in our data.
Perfect. Well, let's unpack those in part 2 of our deep dive.
Sounds great.
I feel like I'm starting to see the world through data-colored glasses now.
We'll be back in a flash. Welcome back. Ready to go from those visuals to actual numbers now?
Absolutely. It's like we've surveyed the crime scene, and now it's time to, collect some evidence.
Yeah, perfect analogy. So let's talk about those measures of central tendency. These tell us about the typical value in a data set. We've got three big ones here: the mean, the median, and the mode.
Okay, I remember those from way back, but
Yeah.
maybe a little refresher.
Sure. So the mean, that's just the average. You add up all the values and divide by the total number of values.
Yeah.
Like if you were trying to figure out the average height of everybody in the class.
Gotcha. So the mean gives us a sense of the center of the data. What about the median then?
So the median, that's the middle value when all the data is ordered from least to greatest. Like imagine you lined up everyone in your class by their height, the person right in the middle. That's your median height.
Ah, so the median isn't really affected by those extreme values, like, that super tall person we were talking about before.
Exactly. If you had one person that was like way taller than everyone else, it would pull the mean up, but the median would pretty much stay the same.
That makes sense.
Uh,
And then the mode,
Yeah.
that's just the value that appears most often, right?
Yep, you got it. It's like think of it as the most popular height in your class, the one that occurs most often.
Okay, cool. So we've got mean, median, and mode, three ways to describe the typical value in a data set. But data could be spread out in a lot of different ways. How do we measure that spread?
That's where the measures of spread come in. They tell us how much the data varies around that typical value. Think of it like ripples in a pond. Are the ripples close together or are they really spread out?
Oh, I like that. So how do we measure those ripples in our data?
Well, there are a few ways. The simplest one is the range, which is just the difference between the highest and lowest values in your data set.
So back to our height example, the range would be the difference in height between the tallest person and the shortest person.
Exactly. It gives you a sense of the overall spread. Now, the interquartile range, or IQR, that's a bit more specific. Remember the box in the box plot we talked about?
Uh-huh. The one that represents the middle 50%?
Yeah. So the IQR is the width of that box. It tells you the range of that middle 50%, which is less affected by those really extreme values than the plain old range.
Got it. So the IQR gives us a more focused look, ignoring those outliers that might mess things up.
Exactly. Now, for the last measure of spread, standard deviation, this one can be a little tricky. It tells us the average distance of each data point from the mean.
Okay, average distance from the mean. So if the standard deviation is smaller, that means the data points are all closer to the average.
Right. It's like if everyone in your class is wearing pretty much the same size shoes, a bigger standard deviation means the points are more spread out, like the ages of everyone at a big family reunion.
Got it. So standard deviation gives us a number that shows how much the data is spread out around that average.
Exactly. And that number is super useful for understanding how typical or how unusual a certain data point is.
Speaking of typical and unusual, my notes have something here about the normal distribution. Is that connected to all this?
It is. The normal distribution, it's a special type of density curve. Remember those smoothed out versions of histograms that show probability?
Yeah, I remember.
So the normal distribution is like the celebrity of distributions. You see it everywhere in statistics. It has that classic bell shape, nice and symmetrical, with the highest point right at the mean.
Ah, so that's that bell curve everyone always talks about.
Yeah.
Why is it so special?
So the normal distribution, it's completely defined by just the mean and the standard deviation. If you know those two things, you know everything about it.
Well, that's pretty amazing. So if we know the mean and standard deviation, we can understand a lot about the data without even having to look at a graph.
Exactly. And get this, there's this cool rule called the 68, 95, 99.7 rule that works with the normal distribution. It's like a cheat code for understanding where most of the data falls.
68, 95, 99.7. That sounds kind of like a magic spell.
It kind of is. It tells us that in a normal distribution, 68% of the data falls within one standard deviation of the mean, 95% falls within two standard deviations, and 99.7% falls within three standard deviations.
Okay, so let me see if I'm getting this. If we go back to our height example, and let's say the average height is 5'8", and the standard deviation is 3 inches.
Then we can use that 68, 95, 99.7 rule to estimate that 68% of the students are between 5'5" and 5'11" tall, because those heights are one standard deviation away from the mean in both directions.
And then 95% of the students would be between 5'2" and 6'2", because that's 2 standard deviations away.
Exactly. And 99.7% would fall within 3 standard deviations, which is almost everyone in the class. So you can see how this rule gives us a really quick way to understand where most of the data lies in a normal distribution.
Wow, that's incredibly helpful. It's like having a map of the data.
That's a great way to put it. And it's used in so many different fields, from understanding test scores to like predicting customer behavior.
This is amazing.
Yeah.
We've gone from visualizing the data to understanding central tendency and spread, and now this secret code for normal distributions. I'm feeling a lot more confident about this stats class now.
I'm glad to hear that, but, practice makes perfect. So before we finish up our deep dive here, I think we should look at an example from your materials just to see how all these concepts are applied in the real world.
You're right. Let's put all our new knowledge to the test. We'll be back in a flash for part 3. Okay, we're back. Ready to put all these statistical concepts into practice with a real-world example.
Let's do it. Looks like we've got exercise example 2 in your materials here, and it looks like it involves a coffee shop.
Oh, coffee. Everyone loves coffee.
Right. So it's their daily customer count over 15 days.
Okay, cool. So what are we trying to figure out here with this data?
Well, looks like we're focusing on finding the mode and median of those customer counts.
Okay, so going back to what we were talking about earlier, mode is that most frequent value, like the most popular customer count. And median is that middle value when you put them all in order.
You got it. So to find those, we gotta get organized first. The source material just has the customer counts all jumbled up. So the first step is to put them in order, least to greatest.
Okay, that makes sense. Put them all in line.
Exactly.
All right, and then once we have that, we can easily pick out the one in the middle, that median customer.
Yeah, and it'll also make it easier to see which customer count shows up the most.
Okay, so let's see. The sorted list from the material is 34, 34, 34, 35, 35, 36, 36, 36, 36, 38, 40, 40, 42, and 42. What do you see there?
Well, 36 definitely sticks out. It appears 5 times, more than any of the other customer counts.
Yeah, I see that.
So 36, that's got to be our mode.
Okay, so 36 is like the peak time for this coffee shop, the customer count that happens most often.
Exactly. Now, what about the median? We have an odd number of data points, 15. So the median is just that value right in the middle.
That eighth one, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it is 36.
That's right. So in this case, the mode and the median are both the same, which tells us that 36, that's kind of like the typical or central daily customer count for this coffee shop over these 15 days.
Okay, that's pretty interesting. But it's not always the case that the mode and median are the same, is it?
Not necessarily, no. They can be quite different sometimes, especially if the data is skewed or if there are outliers. But here, they happen to be the same.
Well, I think we've covered a lot of ground here today. We talked about how to visualize data with those different graphs, and then all about measures of central tendency, the mean, median, and mode. Then spread with the range, IQR, and standard deviation, and even dove into that normal distribution and its magic rule.
It's been a great deep dive. And remember, all these statistical concepts are like tools in your toolbox. The more you use them, the more comfortable and confident you'll be with understanding data.
Yeah. Exactly. So don't be afraid to practice. Play around with those exercises and those real-world examples. Ask questions. And, don't forget to have fun with it.
Yeah, have fun. And keep in mind that statistics, it's a field that's always changing. There are always new things being discovered and new ways to apply what we know. Who knows, maybe someday you'll be the one making those groundbreaking discoveries.
Until then, happy analyzing, everyone.